Hello friends, welcome to Learn with Projects channel. This is second day of statistics Q&A and today we will cover advanced statistics Q&A. So first question is, what are correlation coefficient? A correlation coefficient is a number that measures the strength and direction of the relationship between two or more variables. It measures how similar the measurements of two or more variables are across the dataset. It ranges from -1 to +1. A higher absolute value towards +1 indicates a stronger relationship, while a value closer to -1 indicates inverse relationship. A zero value shows no relation. What is correlation matrix? Correlation matrix is a table that shows the correlation coefficients between variables in a dataset. In this table, each row and column represents variables and each cell contains the correlation coefficient between the two variables it represents. They are used for first, summarization of large dataset to identify patterns. Second, make informed decisions. And third, analyze multiple linear regression models. The Pearson coefficient is a common statistical tool to measure the degree of correlation. Outlier detection. Outlier is a data point that stands out significantly from the rest of the data. It can be extremely high or low value compared to the other observations in the dataset. Outliers can be caused by measurement errors, natural variations in the data, or even unexpected discoveries. Types of outliers are global outliers, stand out from entire dataset. Contextual outliers depend on their surroundings, like the high sale at the clothing store. Collective outliers, groups that deviate together, like a cluster of oddly high values. Outlier detection method for normal distribution, we use empirical relations. The data points that fall below mean minus 3 into sigmoid or above mean plus 3 into sigmoid are outliers. Outlier detection and removal is a crucial data analysis step for a machine learning model, as outlier can significantly impact the accuracy of the model if they are not handled properly. The techniques discussed in this article, such as Z-score and interquartile range, are some of the most important and popular methods used in outlier detection. The technique to be used depends on the specific characteristics of the data, such as distribution and number of variables, as well as required outcome. We will cover Z-score and interquartile range in the upcoming slides. For skewed distribution, we use interquartile range. Proximity rule. The data points that fall below quarter 1 minus 1.5 of interquartile range or above the third quartile, that is Q3 plus 1.5 into interquartile range, are outliers, where Q1 and Q3 are 25th and 75th percentile of the dataset respectively. Interquartile range represents the interquartile range and it's given by Q3 minus Q1, that is middle 50% of the data. There is also third method that use percentile based approach. Data points that are far from the 99th percentile and less than 1 percentile are considered as outliers. Okay. So the next question is, how to detect and remove outliers in Python. First, Z-score treatment assumption. The Z-score treatment assumptions are the features are normally or approximately normally distributed. After plotting the distribution plots for the features, find the boundary values by mean plus 3 into standard deviation. Usually Z-score beyond plus 3 and below minus 3 are considered as outliers. We drop those values and we get the outliers removed. but we ourselves can also decide the cap and remove the data that does not follow the cap range. Second is IQR based filtering, that is interquartile range based filtering. It is used when our data distribution is skewed. We plot a box plot for skewed feature column. We find 25th and 75th percentile or first and third quarter in the dataset. Then we find upper and lower limit, but multiplying 1.5 to interquartile range, adding it to the Q1 and Q3 respectively. Every data beyond this range is considered as outliers. We simply drop or trim the data and visualize, compare the box plot for confirmation. Third is percentile method. We start by setting a particular threshold value which is decided based on our problem statement. We remove the outliers using capping. Then that particular method is used as winsorization. We always maintain the symmetry on both sides, meaning if we remove 1% from the right, the left will also drop by 1%. Visualization techniques used for outlier detection are box plot and scatter plots. The next question is visualization techniques used for outlier detection. The box plot and scatter plots are used for data visualization, can be used for outlier detection. Box plot, it uses boxes and lines to show the distribution of data, including median, quartiles, and extreme values. Outliers are points that fall outside the whiskers, which are typically set at 1.5 times the interquartile range, above and below the quartiles. Second is scatter plot. This plot two or more variables as points on a plane to show the relationship between them. Outliers are data points that are far away from the main cluster of points or don't follow the general trend of the data. Other visualization tools for identifying outliers include heat maps, dimensionality reduction, and anomaly detection algorithms. So, what do you know about stats model and SciPy? Python has powerful libraries like SciPy and stat models that simplify complex statistical tasks. SciPy provides essential function for scientific computing, offering a range of statistical tests and functions that streamline the analysis process. SciPy enhances the capability of NumPy by adding significant functionalities for advanced mathematical functions. This makes it possible to analyze data sets and perform tasks such as hypothesis testing, statistical modeling, and data visualization effectively. By integrating seamlessly with other libraries such as Pandas and Matplotlib, SciPy not only facilitates the complex computation but also enriches the data analysis process, allowing users to derive meaningful insights from their data. For example, chi-square tests and ANOVA. We will cover these two examples further. Stats model is designed for statistical modeling, enabling users to perform advanced analysis such as regression and time series modeling with ease. Integration with data manipulation libraries like Pandas enhances the usability of stats models, allowing the seamless handling of dataset and results. User can easily process their data with the pandas and then apply various statistical tests using stat models. With the capabilities including hypothesis testing, variance analysis, and the time series forecasting, stat model is essential for performing rigorous statistical analysis in Python, making it a valuable tool for analysts across many fields. Examples are regression, hypothesis testing, and ANOVA. Next question is null hypothesis and alternative hypothesis. So null hypothesis suggests that there is no relationship between two variables. Null hypothesis is also exactly the opposite of alternative hypothesis. Null hypothesis is generally what researchers or scientists try to disprove, and if null hypothesis gets accepted, then we have to make changes in our opinion. That is, we have to make changes in our original opinion or statements in order to match the null hypothesis. Null hypothesis is represented as H0. If my alternative hypothesis is that 55% of boys in my town are taller than girls, then my alternative hypothesis will be that 55% of the boys in my town are not taller than girls. Alternative hypothesis is method for reaching a conclusion and making inferences and judgments about certain facts or a statement. This is done on the basis of the data which is available. Usually the statements which we check regarding the null hypothesis is commonly known as alternative hypothesis. Most of the times alternative hypothesis is exactly the opposite of the null hypothesis. This is what the general researchers or scientists try to approve. Alternative hypothesis is represented as HA or H1. If null hypothesis is that 55% of the boys in my town are not taller than girls, then my alternative hypothesis will be that 55% of boys in my town are taller than girls. The difference between null hypothesis and alternative hypothesis are as further. In null hypothesis, there is no relationship between the two variables, and in alternative hypothesis, there is some relationship between the two variables. That is, they are dependent upon each other. In null hypothesis, generally researchers and scientists try to reject or disprove the null hypothesis. In alternative hypothesis, generally researchers and scientists try to accept or approve the null hypothesis. In null hypothesis is accepted, researchers have to make changes in their opinion and statements. If the alternative hypothesis gets accepted, researchers do not have to make changes in their opinion and statements. Null hypothesis, here no effect can be observed. That is, it does not affect the output. But in alternative hypothesis, it affects can be observed on the output. In null hypothesis, the testing process is implicit and indirect, and in alternative hypothesis, testing process is explicit and direct. Null hypothesis is generally used when we reject the null hypothesis, and alternative hypothesis is gets accepted if we fail to reject the null hypothesis. In this hypothesis, null hypothesis, the p-value is smaller than significance level, and in alternative hypothesis, p-value is greater than significance level. Next question is p-value, what it is and how to calculate. A p-value is statistical measurement used to validate a hypothesis against observed data. A p-value measures the probability of obtaining the observed result assuming that the null hypothesis is true. Lower the p-value, greater the statistical significance of the observed difference. P-value of 0.05 or lower is generally considered statistically significant. A p-value can serve as alternative to or in addition to pre-selected confidence level or hypothesis testing. P-value is calculated using integral calculus from the area under the probability distribution curve for all values of statistics that are at least as far from the reference value as the observed value, relative to total area under the probability distribution curve. Standard deviation, which is quantify the dispersion of the data points from the mean, are instrumental in this calculation. Three test types to describe the location on the probability distribution curve are lower tail test, upper tail test, or two-tailed test. Each case, the degrees of freedom play a crucial role in determining the shape of the distribution and thus the calculation of the p-value. Significance level is stated in advance to determine how small the p-value must be to reject the null hypothesis, because different researchers use different levels of significance. When examining the question, reader may sometimes have difficulty comparing results from two different tests. P-values provide a solution to this problem. What are type 1 and type 2 errors? Type 1 and type 2 errors are central for hypothesis testing in general, which subsequently impacts the various aspects of science, including but not limited to statistical analysis. False discovery refers to type 1 error where the true null hypothesis is incorrectly rejected. On the other hand, type 2 errors occur when true null hypothesis fails to get rejected. Type 1 error, also known as false positive, occurs in a statistical hypothesis testing when null hypothesis that is actually true is rejected. In the other words, it's the error of incorrectly including that there is a significant effect or difference there is no isn't one in reality. That means one is not false but is predicted as false. Type 2 errors, also known as false negative, occurs in statistical hypothesis testing when a null hypothesis that is actually false is not rejected. In other words, it's an error of failing to detect significant effect or difference when one exists in reality. What is t-test? The t-test is a type of inferential statistic test used to determine if there is a significant difference between the means of two groups. It is often used when data is normally distributed and population variances is unknown. The t-test is used to hypothesis testing to assess whether the observed difference between the means of the two groups is statistically significant or just due to random variation. Assumptions of t-test. First, independence. The observation within each group must be independent of each other. This means that the value of one observation should not influence the value of another observation. Violation of independence can occur with repeated measures, paired data, or clustered data. Second is normality. The data within each group should be approximately normally distributed. That is, the distribution of data within each group being compared should resemble a normal bell-shaped distribution. This assumption is crucial for small sample sizes, that is, less than 30. Homogeneity of variances. For independent sample t-test, the variances of two groups being compared should be equal. This assumption ensures that the groups have a similar spread of values. Unequal variances can affect the standard error of the differences between the mean and consequently the t-statistics. Absence of outliers. There should be no extreme outliers in the data, as outliers can be disproportionately influence the result, especially when sample sizes are small. Types of t-test. First, one sample t-test. This means a single group against a known mean. Second is two sample t-test. It is further divided into two types. Independent sample t-test compares the mean for two groups, and paired sample t-test compares the mean from the same group at different times or 1 year apart, for example. So the prerequisites for t-test are hypothesis testing, p-value, degree of freedom, significance level, t-statistics, and t-distribution. Next question is, what is z-test? A z-test is conducted on the population that follows a normal distribution, that is a bell curve, with independent data points and has sample size that is greater than or equal to 30. It is used to check whether the means of the two populations are equal to each other when populations variance is known. The null hypothesis of z-test can be rejected if z-test statistic is statistically significant when compared with the critical value. Type of z-test are one sample z-test. It is used to check if there is a difference between the sample mean and the population mean when the population standard deviation is known. Two sample z-test is used to check if there is difference between means of two samples. One proportion z-test. One proportion z-test is used when there are two groups and compares the value of observed proportion to the theoretical one. Two proportion z-test. The two proportion z-test is conducted on two proportion to check if they are the same or not. Next question is difference between z-test and t-test. Aspect is purpose. When t-test compares means of small samples that is less than 30 and z-test compares means of large samples that is greater than or equal to 30. Assumptions of t-test are normally distributed data and approximate normality, and assumptions of z-test are normally distributed data, known population standard deviation. Sample sizes. Sample size is small as we seen before. T-statistics, t-test, for t-test, test statistics is t-distribution, and for z-test, test statistics is standard normal distribution or z-distribution. Degree of freedom in t-test is n1 plus n2 minus 2, and degree of freedom is not applicable in z-test. Use cases are for t-test, small sample analysis comparing means between groups, and z-test use cases are large sample analysis, population mean comparisons. One sample versus two sample. In t-test we use both, and in z-test usually only two sample. Data requirement for t-test are raw data and z-test are also raw data. Complexity is for t-test relatively is more complex and for z-test is relatively more simpler. Z-test is used when sample size is large and the population standard deviation is known, and t-test is used when the sample size is small, usually less than 30, and the population standard deviation is unknown. Now, how to interpret the results of z-test or t-test? Compare the test statistics z or t to the critical value from the z or t distribution table, or compare the p-value to your significance level. For example, 0.05. If the test statistics exceeds the critical value of p-value is less than significant level, reject the null hypothesis. What is chi-square test? A chi-square test indicates that there is a relationship between two entities. Handling data often involves testing hypotheses to extract useful information. In the categorical analysis, chi-square tests are used to determine if observed patterns are likely to be purely random. It is possible that individuals who prefer the color blue also tend to be favor of chocolate ice cream. This test checks whether or not observed data fits those that would be expected, assuming that association is absent at all where there is a huge deviation. Chi-square tests are important in various fields of studies such as marketing, biology, medicine, or even social sciences. That is why they are extremely valuable. Revealing associations, chi-square tests help researchers to identify significant relationship between different categories, aiding the understanding of causation and prediction. Chi-square test check if your observed data matches what you expected. This helps you to know if your ideas are on track or if you need to reconsider them. Chi-square test validate our beliefs based on empirical evidences and boost confidence in our inferences. Assumptions and considerations of chi-square test. Chi-square test suppose that observations are independent from one another. They are distinct. Each cell in the table should have minimum of 5 values in it for better result. Otherwise, think about the Fisher's exact test as alternative measure if a table cell has less than 5 number in it. Chi-square tests do not indicate a causal relationship, but they identify association between variables. What are the types of goodness of fit tests? First is chi-square test. It is mainly used to categorical data and helps in comparing observed frequencies of classes with their expected frequencies based on theoretical model. Kolmogorov-Smirnov test. Anderson-Darling test checks how things Anderson-Darling test. So these are three, and Anderson-Darling test that specifically concerned with the weighted absolute differences between cumulative observed and calculated distributions. When we are talking about the discrepancies of the tail of distribution, it usually is more sensitive to Kolmogorov-Smirnov test. It examines the extent of these disparities as renewed emphasis on tails. This is much more efficient at finding outages in the tails. Punasna. So next question is confidence interval. The confidence interval is range of values that are likely contain the true population parameter, such as population mean or proportion. Based on sample from that population and a specified level of confidence, for example, if we calculate 95% of confidence level for the mean test scores of students, it means that we are 95% confident that the true population mean lies within that interval. So what are the features of confidence intervals? First, range of values. Confidence interval gives us the range of values, not just single number, to estimate where the true population parameter might lie. Level of confidence. It tells us how confident we are that the true parameter falls within that range. For example, 95% confidence interval means we are 95% confidence the true parameter is in the interval. Based on the sample data. Confidence intervals are calculated based on the samples from the population and not the entire population itself. Quantifies uncertainty. They help quantifying the uncertainty or variability in our estimates, considering that the samples can vary from one another. Statistical tool. Confidence intervals are statistical tool used to make inferences about population parameters from sample data. Interpretation. It is important to interpret confidence intervals correctly. They do not give the probability that true parameter is within the interval. Instead, they reflect the long-term success rate of the estimation procedure. Application of confidence of intervals. Medical research, market research, quality control, finance and economics, environmental studies, education and testing, predicting modeling, etc. What is ANOVA and its types? ANOVA or analysis of variance is the parametric statistical technique that helps in finding out if there is a significant difference between the mean of three or more groups. It checks the impact of various factors by comparing group samples based on their respective mean. ANOVA test The null hypothesis that all group mean and equal against the alternative hypothesis that at least one group mean is different. Types of ANOVA. There are two main types of ANOVA, one-way ANOVA and two-way ANOVA. The most basic form of ANOVA and is used when there is only one independent variable with more than two level subgroups are one-way ANOVA. It assesses whether there are any statistical significant differences among the mean of the groups. It is type of hypothesis test when only one factor is considered. We use F statistics to perform a one-way ANOVA analysis of variance. F value is defined as ratio of the variance between samples to variance. Within samples, it is obtained while performing ANOVA test. And two-way ANOVA is extension of one-way ANOVA. Two-way ANOVA involves two independent variables and allows examination of main effects of each variable as well as interaction between them. The interaction effects explores whether the effect of one variable on the dependent variable is different depending on the level of the other variable. We use p value to perform two-way ANOVA test. Assumptions of ANOVA are the dependent variable is approximately normally distributed within each group. This assumption is more critical for smaller sample size. The samples are selected at random and should be independent of one another. All groups have equal standard deviation. Each data point should belong to one and only one group. There should be no overlap or sharing of data points between the groups. In the case of two-way ANOVA, there are additional assumptions related to the interaction between independent variables. The effect of one independent variable on the dependent variable should be consistent across all levels of the other independent variables. Combined, the effect of two independent variables is equal to the sum of their individual effects. Next question is R squared versus adjusted R squared. While evaluating performance of regression model, two metrics often take center stage, R square and adjusted R square. These statistical measures are crucial for assessing how well a model explains a variation in the dependent variable, but they serve different purposes and distinct insights. R square versus adjusted R square key differences are R square considers all the independent variables to calculate coefficient of determination for a dependent variable. And adjusted R square considers only those independent variables that really affect the value of dependent variable. Use of R squared is case of simple linear regression, and adjusted R square is used in the case of linear as well as multiple regression. The range of value for R square is from 0 to 1 and it cannot be negated. But in case of adjusted R square, the value depends upon significance of independent variables and may be negative if the value of R square is very near to 0. The last question is standard error of the regression versus R square error. Objective of R square is to determine how much the strength of relationship between dependent and independent variables. And objective of standard error is that the metric is to find average distance between actual values and predicted values through which the regression line passes. R squared lies between 0 and 1 and standard error does not lie between 0 and 1. It can be different as well. The purpose and use for R square is comparison between two models, and standard error helps determining the precision of the predictions. Interpretation. Higher the value, more is the variability between dependent and independent variable. In case of R square, higher the value, the more the variability between dependent and independent variable. And in case of standard error, lower the value is better, that the model is better. Now, relationship between two metrics. In R square, there is no formula based relationship, but as one decreases, the other one increases and vice versa. So it is inverse.